Hello everyone and welcome back to the course. Now this is going to be our first video in our data modeling section, and we're going to be discussing data modeling in Power BI at length. We're going to be exploring what data model is, why it matters, and how you can start building your own data models in Power BI. So let's begin with simple questions like what is a data model? Now, a data model is essentially a way to organize and structure your data so that it can be easily analyzed and understood. So think of it like a blueprint for your data. Basically, it helps different pieces of data connect to each other. So basically, it helps connecting different pieces of data together in such a way that we can ask questions and get meaningful insights. But before we jump into data modeling, etc., I would like to show us a part of our Power BI where we'll be doing this and tweaking some settings as well, just so we can do this effectively. So let's jump into Power BI quickly. Now, in Power BI, we've looked at the Power Query Editor and we've made some changes, but let's do a little bit of cleanup. Let's go back to the Power Query Editor before we start doing data modeling. So we're going back to the Power Query Editor, and we created a number of queries that we would not need, and I'm just going to be taking them out. So for example, we created Cyprod2 just to show an example. I'm going to be deleting that. We do not need that. We created this query too, and this is just a little bit of housekeeping before we go into data modeling. I'm going to delete this as well, and I'm going to make sure I have everything looking good. Okay. 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 I think we're not going to need this pivot demo any longer, so I'm going to just delete this as well. Sales products. This is where we merged tables. We're going to delete this as well. I don't think we're not going to need this any further. I'll leave this in for now. So let's rename this. Let's rename this guy. Let's call it cycles products, just for consistency. Let's call this cycles products. We're going to leave this in for now. So I'm going to just close and apply. And at this point, I hope you've been saving your Power BI canvas. If you haven't, all you have to do is click on this save button here, or go to file and click on save as, and you have it saved. All right, so let's go into data modeling. Now, one thing you'd notice in your Power BI canvas is you have about 4 different views. If you look to the left, you have the report view, and this is where your dashboard or your report is going to be, your visualization. You also have a table view. Basically, this allows you view your tables, right? And this is not our concern for now. This just allows you to view your tables to make certain changes. You could make some quick changes here as well. What concerns us is the model view. And when you come to the model view here, you would notice that we have all our tables. So we have cycles age group, we have cycles calendar, we have cycles gender, product category, product subcategory region. We have all our tables here. Now, you would also notice that by default, Power BI has decided to look through our data and guess how they are connected and sort of connected some of them. So it has connected cycle sales with cycles age group, created connections for us, which may or may not be right, right? Because again, it just did this based on its own assumption of what is common between both tables. So we are going to be deleting them for now, those connections. So what I want you to do is click on those lines and click on delete on your keyboard, and you would take out those connections, taking it. So we're going to delete every connection for now because we want to be able to create our own. So delete and delete. I think I've removed all the connections. So all my tables are without connections. Great. So now, I also want us to do something else just to be sure we are fine. I want us to go to File and go to, let me move my face away from here. I want us to go to Options and Settings. And when we click on Options and Settings, I want us to go to Options. It's going to open a new window here. Great, for our options. Now I want us to go to I believe it's data load. Now when we go to data load, there's something called relationships here. I want us to remove auto detect. So I want us to check auto detect new relationship after data is loaded. So I want us to just remove this. We can also remove this, but I'll leave this for now. I think we should take it out actually. So let's take it out. So basically so what this is saying is whenever we bring in a new data, I don't want Power BI to automatically assume how the data is modeled and do connections for me. I want to be able to do the connections myself. So if you're done with it, just click on OK. And now we're back to our data. Now, here's the thing, right? A collection of independent tables, just like we have here, is not a data model. You can see we have different tables here: cycles, age group, cycles, calendar, cycles, gender, products category, etc. We have all these tables, right? Well, this is not a data model, and you already guessed why, right? We do not have any relationships between them. They are not connected in any way, right? So if we wanted to visualize, for example, we have, let's say on our sales table, let's look for the joined sales table. You know, since we already have an appended 2019 and 2020 sales table, I don't see the need in keeping the separate ones, right? So I'm going to delete this one. I don't want it anymore. This 20, we have 2019, 2020 stacked on each other. This is just repetition of data. I'm going to delete 2019. I'm going to delete 20. I'm going to delete 2020 from my model too. There's no point keeping tables that we are not going to use. So I'm going to delete 2020. We already have the data in the appended. Remember, we appended 2019 and 2020. We already have the data here. So I'll say if I wanted to find out the way my data is not connected and I do not have the data model, if I wanted to find out the revenue, I have revenue on, I should be able to have revenue on this table, work out the revenue from this table. And I wanted to find revenue across different countries. I would not be able to because I have revenue on one table, profit country on another table, and they are not connected. So I would not be able to find it, or I would get inaccurate results, right? So this is because the tables do not talk to each other. So the data modeling allows your table to talk to each other, to connect with each other. And if they do not connect and if they are isolated, then that's a big problem. So how do we transform this into a proper data model? We transform them using something called relationships, right? So how do we know which table is related to which table? We use common fields, right? So the tables are linked by common fields. I'll give you an example. If we take, let's find the products table. So this is the products table here, right? And it has fields: price range, product key, product new, product subcategory key, unit cost, unit price. And let's find the cycles sales table. right? So we have cycle sales table where we have age group, customer, gender key, invoice ID, product key. We can see that there is a common field here. This table can be connected to this table using the product key table, product key field rather, right? So how do we do it? We just have to just click on this product key and drag it on top of this product key. And now there's a connection, or we are creating a connection. So basically it's asking us how we want to create a connection from this table to this table. And we'll talk about cardinality in a bit, right? We'll talk about cardinality in a bit. So for now, I just want you to click on OK, to click on Save rather, and you would see we have a relationship. Don't bother about the specifics. You're going to go into the specifics in a bit. Let's delete this again. This is just showing us how we can create a relationship. Now, to understand data models, it's essential that we know the difference between fact tables and dimension tables, as these are the building blocks of any data model. Now, what are fact tables? Fact tables, they contain measurable numerical data, right? The actual facts that you want to analyze, that's why they are called fact tables. You may also want to call them uh, data tables. They're also called data tables, but more generally, they're known as fact tables. Now, I want you to think of metrics like sales, quantity sold, revenue. Fact tables usually store this data, and they also store large amount of data because they record every single transaction or event. For example, if you are analyzing sales data, then each row in the fact table could represent a single sales transaction. For example, let's come back to our Power BI and let's go to our table view, right? If we go to our table view and we look at our sales table here, you can see it contains those numerical tables like quantity sold, right? The actual data we may want to analyze. If we also check our sales table, we have another sales table that shows quantity sold as well, right? The actual data we want to analyze, and those are fact tables, right? The each row represents transactions. For example, you can see transaction dates, transaction date, invoice ID. Same for here, transaction date, stock dates, invoice ID, and all of that. Now that's fact table. Now what are dimension tables? Dimension tables provide contexts for the facts. So while fact table gives you the raw numbers, the dimension tells you who, what, when, and where. For example, a product dimension table would provide information about each product, such as name, category, and brand. So here we know, just as an example, that in this particular transaction, the first transaction here, we have product key, product 201. That was what was purchased. But then we know it's product 201. We do not know what product 201 is. We will get what product 201 is in the product table. In the product table. And we can, if we scroll down and we find 201, we would be able to see what, okay, so this is product key 201. So we know that product 201 is a kit patch, and that's the product name. In the product table, we'll find more details about that particular data on the fact table. We know 201 is on the fact table, but we don't know anything about 201. But we have a dimension table called the product table that will give us context about that data on the fact table. So we know the product name, we know the unit cost, we know the unit price, we know the price range, right? So that's basically what the dimension table does for you. Similarly, if we have a customer, if you go back to our sales table, we know, I think we'll find that detail here. We know there should be a customer key. Okay, we do not have a customer key here. We don't have a customer key here, but customer table could also give us more details about customers that purchased our products. For example, we do have a subcategory key, right? And we know our subcategory is 8, but we don't know what 8 means till we go to the subcategory table, product subcategories, and if we search for 8, we know 8 is tires and rubbers. So meaning this person actually bought tires and rubbers, right? So or something from the tires and tubes categories rather. So again, the fact table is at the core of your analysis, right? And the dimension tables provide context to help you make sense of those numbers in the fact table. So that's one thing I want us to understand for now. Another thing I want us to understand is primary and foreign keys. Now, you may be familiar with this from your Excel, from your SQL, and it's basically the same thing, right? In To connect our fact and dimension tables together, we need common keys, right? And primarily, we use the primary and foreign keys, right? The primary key, as you well know, is a unique identifier for each record in a table. For example, in our product subcategory table, we have all these that are unique identifiers on this table. So the product subcategory key is the primary key in this case. If we go to our sales table, we can see that the primary key here would be something that's unique, and this would be the invoice ID for this guy because it's unique for each transaction in the table, right? And a foreign key is a column in one table that links the primary key in another table. So, for example, our product category key, it's a key, it's a table, it's a column in this table, but it links to the primary key in our product category table, right? So basically, if we go to our sales table and we see product category key being one, if we go to our product category table, we see that one is also the primary key. So the foreign key is a table column on one table that links to the primary key of another table, right? So these keys are how Power BI links our tables together. They tell Power BI how that data is related, and basically this also allows us filter and slice our tables as we see fit. So let's go back to our model view. Now, just to buttress, we said Power BI connects data using foreign key and a primary key on one table. So for example, if we want on this sales table, which is like a fact table because it records quantity sold per invoice. If we want to find out which products the customer purchases, for example, we need to get that detail from the products table. So we take there should be product key here. Yeah, there's product key here. We take product key, which is the foreign key on this table, and connect it to the primary key on this table, which is product key as well. Now let's talk about cardinality in relationships. Now, cardinality refers to the type of relationship between two tables and it defines how data flows between them. Now, there are three main types of cardinality in Power BI. There's many to one, there's one to many, there's many to one, one to many, and then there's many to many, right? Now, ideally, you want to maintain a one-to-many relationships in your Power BI model. That's the most ideal and the easiest for now. What is one-to-many? What is many-to-one? What is many-to-many? One-to-many is like the most common relationship. And basically, it means there's one occurrence on the first table can have many occurrences on the second table, and I'll explain it a bit. Let's take the um, let's flip this actually. I want this to be, this is many to one because we have sales going into the product. So I'm going to cancel and I want the products going into the sales. So products key here, primary key here to secondary key, to foreign key. I always say secondary key. So and it's a one-to-many relationship. Now, what does this mean, right? I said one-to-many means there's one occurrence on the first table which is the dimension table, would have many occurrences on the facts table. So let's cancel now. Again, I'm going to cancel, I'm sorry. And I'm going to show us. So let's look at the products table and let's look at the sales table together. If you look at the products table, we have one for 201. There's just, if I filter for just 201, you see there's just one occurrence for 201, basically describing what 201 is. If we see 201 anywhere, this is what it means. But then if let's cancel that filter. Let's go to our sales table, our facts table. Remember, this is a dimension table that just describes basically things we have on our facts table. We go to our facts table. A lot of people would have purchased this particular product. So there are many occurrences of this particular product. So there's one on this table. Let's go to our sales table. Let's filter products key for 201. So you see, a lot of people have purchased product 201. So one occurrence or one observation on the dimension table would match with many dimensions on the facts table, and that's basically what one to many is. And you actually want to keep your data, have your data model that way, just so it's not too convoluted, right? There's also many to one, which is essentially the reverse of what we did before. It works in the same ways, but just I prefer it going one to many instead of many to one. It works the same ways. Then lastly, there's many to many, and this exists when there are multiple records in one table that can relate to multiple records in another, right? It's generally less common and it introduces some complexity and performance issues when you're working in Power BI. So it's better to stick to one-to-many relationships for simpler and more efficient models, right? So we understand what cardinality is, right? And we know what's best. We know we want to keep it as one-to-many. So we're going to just, let's keep this as one-to-many. When you try and join, so that's basically what we're doing is how to actually create relationships, drag and drop, right? Power BI allows that. It has selected a common key for us. Filter direction is single, and this again we're going to talk about filter directions in a bit, right? You want your filter, let's talk about it now. You want your filter flow to be single, meaning uh, you can't filter in both directions, meaning you want to be able to use this products table to filter the sales table. You shouldn't be able to use your sales table to filter the products table because it doesn't just even make sense. It's for efficiency reason. You want to be able to use your dimension table to filter your facts table because it's your facts table that needs filtering. That's where all your transactions are on. So one directional flow. So let's do that. Another way to actually create a connection, which is a longer way that I don't like, is to actually use the manage relationship dialog. So here it's longer, it's much longer. If you click on manage relationship, you can create a new relationship and then you select your table. It's longer. Products. I want to select between product and sales. Let's do sales 2019-2020. I'll select my common keys, primary product key here and product key here, one to many, single direction, and click on save. And it will create that relationship for me. Yes, it's a relationship. Yes, so I can click on close now. It has created the relationship for me. Remember, I used 2019-2020. So this is it. Relationship. I mean, it works, but I really do not like it. So here, now we know how to create relationships. We know what cardinality is. We've talked about filter flow. Let's talk about models, right? Let's talk about the two most common data structures in Power BI. There's something called the star schema. And the star schema is the simplest and most popular data model structure. Now, in a star schema, you have a central facts table, like what we have for sales, surrounded by dimension tables like products, customers, etc. Right? The fact table is directly linked to each product table. So we're gonna do an example now. Let's move sales out of the way for a bit. I'm gonna just zoom in. So this is my facts table here, my central facts table. Again, it contains all the transactions, the daily transactions, and all the measurable fields. This is my fact table. Now, it's a fact table surrounded by all the dimension tables, right? So I have connected products, which is a dimension table. I have another dimension table, which is regions. I would connect it using the region key. There should be a region key. Hold on. So let's analyze this well. It's actually named region key on the region table. I'm saying it as called sales territory key. let's look for an example. I'm going to go. I want to ensure that they're actually the same thing. Region key and sales territory key. So what I'll do is I'll go to my sales table, my table view. I'll go to my sales table, right? And region key is numbered from 1 to 10. I see region key is numbered from 1 to 10. So I'll go to that regions table and be sure that I have 1 to 10 in it as well. Regions table, and okay, you can see it's numbered from 1 to 10. So they're actually the same thing, they just have different column names. So again, you may have the same key that actually mean the same thing but have different names. So that's just something to note. So let's go back to this, and I now know for sure that region key and sales territory key are the same thing. So I'm going to do, sorry, again, I want to do one to many. Sales territory key to region key, and then I would save one to many. I'm fine. This video is getting too long. So okay, so we have this. We also have other tables. We have product subcategory. Let me get product category first. We have product category. We don't need product subcategory. We'll talk about this later. Product category. Okay, we actually could use product subcategory. So I'm going to drag product category into product category key, save. What else? What else? What else? What else? I think we have gender. Do we have gender? We should have gender. And yeah, we have customer gender key. We have customer gender key. I'm going to just drag that as well. Gender one, save. So what we're building here is a star schema. So you can see the facts table is in the middle and it's surrounded by, I'm going to move this here. This is another facts table. And it's surrounded by all the other dimension tables. Let's do subcategory as well. So product category, this is category, this is subcategory. I can actually use this as a snowflake in my snowflake filter. Actually, it doesn't make sense to put this here. Let's do age group and calendar. So age group, do we have age group in the facts table? Yeah, we do. We have age group, so I have age group. Save. Lastly, I will do I'll do calendar. Lastly, I'll do calendar. And to be date. I want to filter my transaction date. So I want to just link it to my transaction date. Date, yeah, it will work. So date. So here, this is a star schema. You may ask why I left this. This is another facts table. Again, it records transaction. If you zoom in a bit, it records transactions and numerous. So it's another facts table, right? So I'm just leaving it out for now. This, I want to use this to explain snowflake filter, the snowflake schema. So I'm leaving this out of purpose, right? So here, this is a simple star schema. We have our facts table in the middle, and it's surrounded by all the dimension tables, and this is a simple model. This is the most popular data model you'll find. It's called the star schema, right? So it makes querying very fast and intuitive, right? So you basically, it's recommended for beginners, right? And this is good. Another popular one is the snowflake schema, and it's a more complex variation of the star schema, right? And it's so for to talk about snowflake schemas, I may have to delete all this. I would use this cycle sales table. So you know what? Let me not delete everything. Just so let's delete just the products category. Now, using this as our second facts table, I'm going to just move this guy here for now, so we can focus on it. Using this as another fact table, which we can't have two different facts tables, so I'm going to have to just delete one at the end. but this is for teaching purposes. Using this as our second fact table, we would see that we can't actually connect, we can't get details about. So this other fact table has subcategory key, so we could actually connect the subcategory table, which I purposely left out if you remember. But this guy doesn't have subcategory key. We can connect products to this using the product category key, right? So we have product key here. No, we should have product key, not product category. I'm going to have to remove product category, product key as well. Where's my product? I'm going to delete this as well because we will need this. Okay, so let's bring products here. And I would need you to use your imagination a bit. I want you to assume that all these other guys here that are surrounding this fact table here are also surrounding this guy. We have a region, transaction, date, age group. They are all surrounding this guy. But let's focus on this. So product, I can actually join products key with products key here and have a one-to-many relationship, right? But I cannot get details about the product category and product subcategory because this fact table does not actually have product category and product subcategory key the way this fact table does. What we'll do now is called a snowflake schema, right? And basically it's where a dimension table can be further normalized or can be split into other related tables. So we can split product table into product category table, can further split product category table into product subcategory. So we can just, here we have product category. Let's move this a bit. Let's move this a bit. So we have product category here, a product category here. So we have a product subcategory actually. So we can actually split this into product subcategory. Product subcategory here. And we have one to many. And we can actually further split this into product category here. And now you can see this is like a snowflake. And what does a snowflake look like? Hold on, I'll get you guys a picture. So here's the image of this image of the snowflake. The model is trying to replicate, right? So you have one model connected and one query connected and other tables or queries connected to that table. So that's snowflake schema. I would advise you keep things to a star schema for now. So yeah, that is data modeling basically. So quickly, I'm gonna revert back to our our model that we had before. I'm gonna just delete these ones and delete these ones. Delete this one. So let's go back to our star schema and make those connections again. Products category. We have a products category key. Oops. It should be product category key, not product category. Product category key. Now I will join my subcategory key as well. Just because we have the product subcategory key. Actually, yeah, I should actually still leave this here and join this like this. The reason why I'm doing this is because I want my let's just join it directly. Subcategory key. And yes, subcategory. I feel like we're missing one more. Yeah, products key itself. Products key would also join to products key here. Okay, we have our star schema. I'm just going to keep these sales. We're not going to use it. I'm just going to keep it. So you're not going to use it in a visualization or anything. So that's data modeling. Just some pro tips, right? To wrap up this session, right? One, always aim for a star schema whenever possible, right? Structure your data model in a star schema. It's simpler to work with. Also, use one-to-many relationships, right? Avoid many-to-many relationships. They tend to be very complicated and can affect your performance or the performance of your visuals. And simplify your models, right? Only include the data or tables that you actually need. So you see, we deleted some of those tables that we did not need. Um, you could also use descriptive table names, right? So see, I have Cycles products, and we renamed that PsycProd into Cycles product because it wasn't really descriptive. So there you have it. We've covered the core concepts of data modeling in Power BI, including facts and dimension tables, primary keys, foreign keys, cardinality, difference between star, snowflake schema. And in the next video, we'll start looking at some visualization tips. So stay tuned and see you in the next video.